All right, guys. So today we're looking at some of the learning that we practiced yesterday around measures of center.
I still don't get the MAT or what.
So we're going to practice that quite a bit today.
Mad.
Yeah.
I'm mad.
First of all, makeup tests. Tonight I'm going to be grading your test, so I don't know if anyone in here has, they need to finish their test, okay? But if you do, you need to find time to do that. I'm not going to track you down. It just goes in the grade book as 0, so be responsible. Warm up and exit ticket. If you were not here yesterday, we collected those, so if you were not here, you want to make sure that you pass that in. Warm up and exit ticket from last week. So we have this data set that represents the number of 7th graders who got a 94% or above on the last 7 tests in math in here. So you can see we kind of started off on the lower side. You know what unit that was? That was the algebra unit. That was that hard one. And then we've done really well since then. So what is the mean of the data set? And how do I find out what the mean is? Fabian, what do I do to find mean?
The mean?
Yes.
You add up all the numbers and divide it by 7.
Okay. I would add up exactly. I would add up all those numbers. And I think that equals 135?
Yeah.
So if I add up all these numbers, I'm going to get 135. And just like Fabian said, I'm going to divide by 7 because I have 7 values in the data set. So depending on how many values I have, that's what I divide by. And then I get like 19.3 if I round. And we're going to actually round it to the ones place. So it's just going to be 19. So that is how we find the mean. But explain, what does that number mean? Good. Yeah. What does it mean? Logan.
Okay, so the mean is all the numbers added up and then divided, so it's like the average
It's the average. Average of what?
of a certain set of data.
Okay. Yeah, it's a value. So mean finds the average value. And you need to understand that is different than median, which is
The
the
middle.
middle. Like literally the physical middle. If you take all the numbers, where's the middle of that? Grace.
Mean.
When it says explain what that number represents, it's like that means, so if I said this means for every test average amount of people who scored 94% was about 18.
Yes. Yep. So this number 19 means out of everyone that took, out of all the kids that took the test, we averaged 19 kids above 94%. Out of 90, I guess it varied throughout the school year, but 94 to 97. So 19 kids scored above 94%. And that number as a mean represents a average value. What about, what is the median of the data set? Sarah, what'd you get? How'd you do it?
I got 18, and I did that by by listing out the numbers in chronological order, and then crossing out the end ones at the same time until you reach the middle.
So you put them in ascending order.
Ascending chronological set of order of time.
Yeah, it's all right. I totally understood what she meant. So we got them in ascending order from smallest to largest. Descending would be the other way around, biggest to smallest. And I'm going to do exactly what Sarah said. I'm going to cross off on each side. And then I'm left with, and that is, so median is a physical representation of a data set. It is literally the middle of it. Now, both of these are called measures of center. And that's important for you to understand, that there are 2 ways that you've learned right now to measure the center of a data set. That 18, what does that 18 represent as a median, Sarah?
It represents the middle of a data set.
The middle of the number of 8th graders who scored,
Seventh
7th
graders.
graders who scored 94% or above.
Everybody just.
So that's the middle of that data set that represents the 7th graders taking or scoring above 94%. What is the mean absolute distribution?
Deviation.
Yeah. Deviation. Not.
You said distribution.
I know I said distribution.
You also wrote that.
Cody.
I said 5.
Huh?
I got 5.
Same.
Yeah. It's 5.
Yeah.
So how did you do it, Cody?
So what I did was 18 minus 14, which equals 4. And then 18 minus 16, which equals 2.
Wait, I thought it was 19.
I did too.
Is it 18 or is it 19?
It's
19.
19.
Yeah. Which is actually 5, and then 3.
Because that's going to change, but it won't change by much. You'll be rounding down instead of rounding up. 5, 3, yep. And then 19 minus 11, which is 8. 19 minus 18. Whoa, that's crazy.
What the heck?
That was cool. 1. And then 22.
Minus 19.
So remember, when you're finding the mean absolute distribution or deviation, I wrote distribution, deviation, we have, it always has to be a positive value. It can't be negative, otherwise it won't work.
It switched colors because you know if the red one.
I know. But that was weird why it switched though. It was just like,
The red marker.
No, if you
down.
pick it up. The red marker's not in there.
I know, but why?
Why?
Because it like detected it, I guess.
The red was already out.
Oh, maybe your hand got so close it detected the red marker being there, then you were.
So when I add up, how many values should I have up there?
7.
7. Should have 7 values that represent the difference between the mean and each of the test scores. What is all, when you add up all those, what do you get?
Mean absolute.
Should be around 30.
36.
Thank you. 36. And then I go 36
By 7.
divided by
7.
7. And you get 5.1.
3.
Or the mean absolute deviation.
So what does that 5.1 mean? Yes, it's the mean absolute deviation, but what is it? Like, explain it more. In the terms of our data. Tobin.
It's it multiplied by 2 and centered around the mean is the estimated range.
It's the range of what? It's the estimated range of the amount of kids who scored 94%
Right.
or above. Okay? It's like the average mean range, if you want to look at it that way. Okay? Of the amount of kids who scored 94% or above.
Average.
So, average mean range.
Average and mean are the same.
No, they are not. So, if my mean was 19, I know I go 5 up and 5 down. So, my range of kids scoring above 94%, my average mean range is 19 to 24, which is a pretty big range, right? That's not what, when in terms of standard deviation or mean deviation, is it better in testing purposes to have a larger or smaller deviation?
Smaller.
Smaller, because that means what?
Then you're more accurate. Consistent.
More consistent, yes. And that majority of the kids are doing well. Okay, when you get a big distribution, okay, big deviation, you have kids that ace it, and then you have kids that tank.
What if they're all
all super high scores and some are just like super duper high.
Then you would have a very small. I see what you're saying.
Well, no, if
you have
like,
high
a wide
scores
range
and
that's
super high scores. It's possible.
But that
It's possible. It is possible. It could be that. But then I would have to say then the test isn't what I would call very valid, right? Because I don't make tests for 80% of the kids to get like a 98 on, right? My job is to see what you know and what you don't know. That's why in here, our variation is smaller, but still we range from C's to A's.
what?
Okay, in this class we do. So.
Really?
Wait.
Any questions about this?
Yes.
Emily?
Okay, what does mean? What's the definition?
It is the average of a value set.
What
You
is
take-
the definition of average?
Okay.
You just said that mean and average were completely different.
I didn't say they're completely different.
Said
Yeah, you did.
They're- well, they are different. They are not the same.
They're spelled different.
No.
No,
it's just confusing.
Wait, no,
because
average is
different.
in means definition.
Yes.
But then you said that they're not at all alike.
Right, because average doesn't mean that you're getting it from a data set that represents.
But they're still the same.
It has to come from somewhere.
But they're just not.
They're very similar,
It's not
yeah,
a
but
set
you don't want to pick.
of numbers.
You just said that.
Oh, right?
They are, and they are similar as well. They're different and
I don't
similar.
understand how they're different.
That's
Like,
like
well,
either
more
different or
Maybe tomorrow I'll show you why. Today. Today we have so we have this idea of evaluating numerical outcomes. What is an outcome first of all? Like we have these numerical outcomes. What's an outcome?
Result. A thing that
It's a
can-
result. Good, thank you. So an outcome is a result. So you get results all the time. What we're going to look at is how do we evaluate results? We evaluate results through two methods that we're going to be looking at. One is the measures of center. That's the median and the mean. And the other one is the measures of spread, which is the range and the MAD.
What happened to mode?
Okay?
Yeah, what's mode? I forgot.
It's the most highest occurring.
Most
Oh, yeah.
current
So the
data
mode of that-
entry.
The mode of that is like, what's the mode of that?
So there isn't because there isn't one that they're
All
all.
of them are
But if there was two 11s now.
So these are the ways that we actually evaluate our outcomes, our numerical outcomes. So Mrs. Harris, she has her and her husband run an office. And through their office, they're constantly using mean, constantly looking at range, constantly looking at what's their deviation. And they do it by like figuring out how many clients per day. What does my husband make per hour based on what he gets paid from insurance? How does insurance affect his overall paycheck? They look at all these things. And some of those measures come from that. The skills that you're learning today or have already learned. So the reason why I bring that up is that these are very, very applicable to like what you might be doing later on in life. They get used a lot. And the reason why is they help you analyze numerical outcomes, results. And the more you analyze your results, the better and more fine-tuned you can get those results in your favor. So, any other questions around this? Okay, we're moving on. You can put your homework on your desk. Yesterday, I believe in here, we're almost. I'm going to give you guys about 5 to 10 minutes to finish down to D. So I'm going to give you 10 minutes, and then we're going to start today's lesson. So get out yesterday's work.
D had only 3 or 4. So yeah, I did.
Can I use that?
Now I just gotta focus on staying awake.
Okay. Yeah, you can work on tonight's homework. It's right there. if you are done. But I want to have it out because I'm going to be coming by to check it.
Wait, did D only do have
No, that's for test.